Sky.
It's actually the sand of the the seabed. Not seabed, but the lake bed. If I go up there, I can see the sky there. Come down, I see the ground, but I'm supposed to see the car, right? Furthermore, this window here is not reflecting the mirror. There are other problems with this reflection too. Normally, when you look at a car this way, you would expect to see reflections down here of part of the car reflected in the car. That's called self-reflection. OpenGL does not do self-reflection. To do self-reflection, you need ray tracing. So this application, just by pressing R, lets me go into ray tracing, and now you'll see that there is a mirror reflected in the window, and the car, especially if I change my angle, is now reflected in the mirror. Furthermore, there's reflections going on down here behind the wheel arch, which are exactly right for a car self-reflecting. This is now accurate, and this can be trusted by the stylists at the automotive companies. But it uses ray tracing, and ray tracing is computationally expensive. All right? Now, cool thing about ray tracing, and this is actually an interactive ray tracing application. You can see that I've got it set so the quality is down a little bit while I rotate, but you can certainly see all the reflections you need to see, including this strange reflection of the mirror. And then when I let go, it progressively cleans up, just as long as this progress bar is continuing. It's parallelized. Ray tracing is the poster child for a parallelizable application. It's the best. So what hardware have I got in here? Well, this window here, let me put it up on the big screen. I have to kind of go down and then up. This hardware, totally saturated. It has 24 of these little windows, and that's because I have got two Xeon X5680 processors. So there's a Westmere, 3.33 gigahertz, 6 cores apiece. So I have a total of 12 cores of hardware in this workstation. And then in my BIOS configuration, I turn on Intel hyperthreading, which you're probably familiar with. Hyperthreading allows 2 threads to run on every single core. So Windows thinks that every core is actually 2 cores. That gives me the 24 cores that this application can use. And the coolest thing is that as I put that there, as I do ray tracing on this, it uses everything. You see I'm up to 99% here. And then when I let go and let it run at full quality, it even reaches 100%. 99, 98, sometimes it's 100, who cares? All right. Well, the point is, it is totally maxing out the processors. So far, what you have seen, you've seen the graphics card, which is a NVIDIA Quadro 6000, one of the new Fermi high-end cards. You've seen the graphics card doing graphics. You've now seen the CPU doing graphics by ray tracing. Let me show you something else. Oh, here it's, I'm just going to finish in just a minute. There we go. High-quality image. This application, let me just pull this one down up to here for now. This application is an application called, SHOT, and it comes from BunkSpeed. And if you've been following BunkSpeed over the last couple of years, they've had some seismic shifts in the company, but SHOT is the product that is promoted right now. And it's a very good product. It's focused more in the automotive space than Showcase, which can be used for cars and cell phones and motorcycle helmets and everything. SHOT can be too, but I think automotive is where they're primarily marketing. So I'm going to start moving this car around. Once again, I'm getting interactive ray tracing. You can see the quality is somewhat decimated so that my interaction is nice and quick. And then as soon as I let go, it starts progressively cleaning up. That's what you want out of one of these applications. My CPU, 3%, 5%. So it's doing ray tracing, but not on the CPU. So where's it happening? Over here I have GPU monitor. You can see I've got 2 traces here running at 90%, 90%. Why 2 traces? The reason for that, so yeah, I'm going to be damaging everything while I continue. I actually have 2 Quadro 6000s in this workstation. So with the two 6-core CPUs and two Quadro 6000s, I have a killer workstation here. It's very, very high performance. And the cool
thing, you have a kilowatt supply too.
Yes, a kilowatt. Actually, the power supply is 1.1 kilowatts here. So at full poke, it can be drawing a good 10 amps or more through the cable. Unless you're in Europe, in which case it's only 5 amps, right? Twice the voltage, twice the power. All right, so let me just show you something extra cool.
Hey, Dan.
Yes, Jim?
I have a question.
Yes.
So I'm a customer. I've got a 3-year-old workstation. And I saw your demo. You had me at Z.
Oh, really? Yes.
I have a 3-year-old workstation, which is probably
XW8400.
dual core CPUs.
Be dual core, yeah.
Dual
Okay.
cores.
Yeah.
And now I want to step up to this. What kind of an experience difference will I have on these apps?
On these apps, it will be huge.
Like,
Just huge, maybe 10x or probably more. 15, 20x.
so think about
Easily.
Think about a 10-time return on investment for your most highly paid people for a few thousand dollars.
Right. So here's a metric to take away with you. For this application, for this vehicle, this model, I can change this application between using the CPU or the GPU. With these GPUs, it runs more than twice as quickly as it does on these CPUs that are in the box.
Can you use both at the same time?
With that application, yes, you can, and the performance is somewhere in between. They're still working on the heuristics. It's really hard to do because you have to match memory footprints and so on. But yes, you can. So what I was showing here was I now have this thing doing ray tracing and that thing doing ray tracing. No, it's not. It will be when I click on it. So I have the CPUs running at between 90 and 100%. I have these running at 86, 87%. So this workstation is working really, really hard for its lunch, like me, right? So it's a complete powerhouse. And the cool thing is, I can get the full performance out of these two applications simultaneously because I'm using different subsystems in the same workstation. Right? So for example, I might be using that uses GPU compute, and somebody else in my work group might be using my CPU to do some offline rendering under the auspices of RenderMan or something that manages ray tracing jobs. Great. And a workstation that can apply high performance to two completely separate tasks. Any questions? I think the quietest bunch so far, yes?
So you mentioned that running on the GPU is faster than running on the CPU, but you've only got 2 graphics cards, and I know they've got up to like quad SLI. Have you guys, do you guys have a system that would support that?
Not in a workstation chassis. The amount of power you would need to feed that, you pretty much have to have a custom chassis for that or go into a server type of configuration where you'd be using Tesla cards like the one that's there, which I'm coming to in a minute.
And Dan also explained what I'll call a practical limit. So we have an 1100 watt power supply and we're using 10, maybe even 11 or 12 amps, depending upon efficiencies in your office and so forth. How many of you have got 20 amp circuits in your office? None of us. Because for us to step up to a 1500 watt or an 1800 watt power supply, we could do it. We could build one in a workstation. We could put more in it. But we wouldn't be able to deploy it in the office environment because most offices are wired for 15 amp around the world. And so the result is we got a pragmatic limit in terms of what goes in the office versus what potentially needs to go into a special lab environment. Now in our lab, as you guys all saw, sure, I can run 20 amps back there all the time. This doesn't bother me at all. But that's not a practical environment for the end user. So we continue to work with both Intel, NVIDIA, ATI to understand how can we keep the power limits pragmatically in line, but still achieve the incredible performance. So it's not like we don't want to put more power in there, but we understand what I'll call the customer environment says, if I build it, they won't come. So we got to be very pragmatic about that as well.
Could you scale down the CPUs and then, as far as power goes, and then put more of the effort in the
Not
GPUs?
enough. Okay. I can't get enough power out of it. I mean, in the CPUs we're at 130 watt.
Yeah.
130 watts. Okay, so I can go to 90.